Enceladus is the sixth largest moon of Saturn, with a diameter of 504 kilometers. Enceladus is one of the brightest satellites in our solar system, which is dominated by pure water ice. Post-Voyager data suggests that it was impossible to reach the melting point of ice under the current physical conditions. However, the presence of ammonia could lower the melting point of ice water to account for the presence of liquid water. The water-ammonia mixture could help drive the process of cryovolcanism that may have resurfaced this body. 3 different flybys were performed by Cassini in 2005. The first, at a distance of 1,259, detected a tenuous atmosphere, which distorts Saturn's magnetosphere. This also confirmed a surface dominated by water with simple organics and CO2. The second, at a distance of 497 kilometers, concluded a magnetic signature, confirming a southerly atmospheric source of water ion mass. The third, at a distance of 168 kilometers, allowed a high-resolution investigation of the South Pole environment, revealing house-sized ice boulders and carved tectonic features, which are almost impact crater-free. Also, a plume of water vapor and small icy particles are emanating from the southern polar region. The tools used in this investigation included the Visual and Infrared Mapping Spectrometer, the Imaging Science Subsystem, the Cassini Composite Infrared Spectrometer, and the Ion and Neutron Mass Spectrometer. South polar terrain of Enceladus is distinguished by its tectonic patterns, youthful geology, unusual albedo, and color patterns. Tiger stripes are linear depressions typically about 500 meters deep, 2 kilometers wide, and 130 kilometers in length. Albedo differentiates the Tiger Stripes area, which possibly is due to geological activity of present-day venting and particle fallout. Bright surfaces are likely derived from a covering of fine-grained regolith accumulated from impacts and particle fallout. This covering is absent on the Tiger Stripes either because of the recently emplaced material or due to thermal processes. Enceladus has the largest range in crater number density, implying a record of long-lasting, possibly still ongoing, geologic activity. Ages within the south polar terrain are 500,000 years or younger, possibly experienced localized episodes of activity to account for these ages. The shape of Enceladus has been determined from limb profiles in 23 narrow-angled images. The satellite Enceladus is well represented by an ellipsoid. Plumes have also been detected in the South Pole region. High phase angles images revealed near-surface jets that implied a larger, more faint plume that covers the South Pole region. Jet source seems to be consistent with the Tiger Stripes. Most of the particles coming from this region fall back to the surface. However, those that do not reach the surface escape velocities supply the E-ring. There are 2 possible sources for these jets. One could be due to the sublimating ice either above or below ground, or 2, these may be underground reservoirs of boiling liquid erupting through Tiger Stripe vents. Proposed models for plume sources imply large temperatures near the surface. Boiling liquid model is favored, and the chambers could be as close as 7 meters to the surface. Heating could be provided by tidal forces and/or frictional heating. Since ammonia is needed to lower the melting temperature of water ice, it is thought that ammonia is present on Enceladus, but there is no concluding evidence that it is present. There are many fractures that occur on the surface of Enceladus. This may be because of upwelling of water vapor, or the planet may be tectonically active.